Good morning, everybody. Good afternoon, everybody. I'm Lene Guiar from Counter International, and I'd like to welcome Cor Merks and Tomislav Vitovski for the presentation today. Just a few warnings before we start. After the presentation, we have time for the questions, so you can use the Q&A box in the bottom of the Zoom page. Please use the option sent to everyone, not only to the presenter. Cor Merks, Tomislav, you are free to start whenever you want.
Hey, thank you very much. Indeed, good morning and good afternoon to you all. Very nice audience. It's a joint presentation by Tomislav and me. and reason for that is that it is about active leakage, active leak detection at a utility in the Netherlands, Vitens. I know that utility, but Tomislav for sure knows how to detect leaks. So I'm presenting a little bit on Vitens and the setting we were in, and Tomislav will then detail the training program that we did for 2 weeks with utility staff. Vitens is at the moment the largest water utility in the Netherlands, and you can read from the screen. It's a public utility, 24/7 excellent water quality, covering 5 provinces of the Netherlands. It supplies about 350 million cubes a year. It's the light blue area I'm pointing at the screen. So more or less, these are the 5 provinces, 1, 2, 1 here, 1 there, and 1 there. This is the logo of Vitens. You will recognize it on all of the slides. It does the job with 1,400 employees and some freelancers that are being hired for specific tasks. And I'm one of those freelancers because they hire me 1-2 days a week as the non-revenue reduction coordinator. Vitens operates 100 water treatment works. So more or less, they have dedicated water distribution networks outgoing from 100 waterworks, but the interconnections are there for ensuring security of supply. So we'll see on one of the next slides is one large open water distribution system that consists of a variety of water distribution networks. It totals 50,000 kilometers of mains, and of course a lot of length of service connections not included in this 50,000 kilometers. And it invests about 200 million euros a year in new assets and in asset rehabilitation. Leakage is low. And Ellen, you're there. You're amongst the people that don't like the percentages, but also in the Netherlands, it's still the performance indicator that we use most. And typical for the Netherlands is a percentage between 5 and 7%. So that's low. And still there are drivers to invest in water loss control. And the drivers are the most important at the moment is improving sustainability. But as Dutch water utilities don't supply drinking water with residual chlorine, to avoid a burst is very important because each burst can result in contamination of the water inside the distribution network. So it's also a matter of ensuring public health. It's avoiding inconveniences. Repairs and bursts are inconvenience for your clients. It's also to do targeted investment in infrastructure and robustness. Vitens is asset management certified. So that means that they work also with burst frequencies in decision-making on which pipe, which main to replace. And related to sustainability, it's important to understand that given the large size of this utility with 100 waterworks, there are even in the wet country, the Netherlands, where water is abundantly available, there are areas where groundwater resources are limited. So there's really a regional lack of fresh groundwater for drinking water production. Already said, it's one large open distribution system where at each waterworks, but also at well-defined and well-selected points in the distribution network, flow and pressure are being measured. So The graph on the left is the Netherlands, with in blue the one Vitens, the one utility. That's more or less for operational purposes divided in 10 clusters. That's the graph second to the right. All those clusters are divided in a number of water balance areas. So not each cluster has a large number of water balance areas. So I give an example. The smallest province, Flevoland, is only divided in 3 water balance areas. But the cluster Gelderland Noord, on which we have been focusing last year, is already split up in 10 water balance areas. And then there is even a further subdivision of these 80 water balance areas in a total of 189 water balance zones. So more or less by flow and pressure management, continuous and monitoring, that's the way that Vitens operates this large open distribution network. So when starting the exercise with Vitens October 2020, so close to a year ago, we used both 4 pillars diagrams on leakage management for real losses and for apparent losses. And then we came to the conclusion that for Vitens, having almost everything very well in place, there are only 7 specific topics to pay attention for. I will rapidly go through them, but it is the network flushing for water quality control, a very limited volume used for that. The network flushing for new distribution systems and supply customers. The number of customers in the area is gradually growing. So new networks have to be installed and flushing is necessary to have them hygienical in place. Apparent losses. The biggest point at the moment is the aging of the customer metering, the residential water meters, which on average show an under-registration of 1.8 to 2% at the moment. And the replacement program is scheduled to start mid-2022, so next year. There's almost 0 unauthorized consumption, but we are still checking that. And then with respect to the real losses, the reported leakage is very low. It's once again expressed in percentage, 0.1% of the total volume of water supplied. Yes, there is background leakage. I'm very happy that Ellen is helping me out in making a proper calculation of the unavoidable background leakage of Vitens using the right formulas and equations. But there is also some unreported leakage that can be detected. And this requires a little bit of the explanation of the 2 figures that you see on the right-hand side of the screen. Of course, everyone will recognize this as an easy detectable leakage, and those are detected and repaired very fast. This is an example of the dynamic bandwidth monitoring that Vitens uses on each of the 100 waterworks and each water balance area to monitor what is happening inside such a water balance area. And what you see here is more or less a projection of the water that has been flowing through this water balance area. There is a dynamic bandwidth of about a number of percentage defined to avoid that each incident, each peak in flow would lead to an alarm. So everything outside the bandwidth, and in this case you see here a clear flow that is absolutely outside the bandwidth, is then resulting in an alarm. That means that each large leak is detected by this dynamic bandwidth monitoring, and there are also 2 other continuous digital tools monitoring the network. One is called the leak monitor, and the other is of course the minimum night flow monitor that helps in detecting burst. And this also indicates that there is room for slight improvement because everything that is inside this bandwidth, and if that bandwidth is, let's say, 10% of a flow of 400 cubes, then you can clearly calculate yourself that there's then some 40 cubic meters per hour leak that is not monitored by this dynamic bandwidth monitor. That should then come from the leak monitor. So more or less, that's also why we have defined there is room for trying to better detect leaks smaller than 25 to 30 cubes an hour in general. And that's where Vitens has recognized that this is a skill they don't have abundantly available. There's one expert that has some tools and spent some time on active leak detection, with one expert on a staff number of 1,400. You can imagine, and this size of the network is not that much. So together with 2 team managers, we have developed an active leak detection training program. It's tailor-made, specific for Vitens, consisting of 1-day classroom training, 2 short classroom evaluations. Each Friday, we have been sitting and working together to discuss what we have discovered and learned during the week, but also 9 full days of field training conducted by Tomislav and his team. It's a training thereby by professionals for professionals, because the Vitens staff are good mechanics and know how to repair a leak. As mentioned already, focus was on the water distribution network in the province of Gelderland. We had to focus on one of the clusters to learn as much as possible from that. And due to the fact that there was not really a history of bursts, we did the localization done within Vitens predominantly based on the minimum night flow monitoring. The results, of course, are available, and on a history of mains burst over the last 5 years. So the localization is something that Vitens did within this cluster themselves. And this is also one of the starting points for Tomislav in his training. And I'm happy to hand over to you now, Tomislav. You have to unmute yourself, Tomislav.
Sorry. Thank you again, Cor. I want to just thank everybody for joining this webinar. Well, regarding this first day in Vitens, we gather in the classroom just to do the training of the staff. There was at least around 20 people attending on the training, and we started doing from the basics, because 90% of them never met the leak detection. Only 1 or 2 guys that was attending was know what is the leak detection, how to perform the leak detection on field. So we start from the basics, from the noises, what's noises, what caused the noises, and from step testing, all the basic things that they need to understand how the noise is transferring from the leak or through the pipe, depending on pressure, pipe materials, and stuff like that. The focus was on the LLP methodology, so localize, locate, and pinpoint, where I tried to explain that in the entire section of their clusters and everything, they need to first localize where to look for the leaks. I mean, like Cor said, they didn't see any smaller leaks than 20 to 30 cubic meters. So explanation first was the localize, where to search. Then after localize, to locate the leak and the pinpoint with the equipment. After that, we just showed the technical presentation of the equipment with the correlators, ground microphones, ultrasonic flow meters, everything with we are going to do on the field. So after that one day, the next day we started doing our field work. Okay, Cor, next slide. Next slide, Cor, please. So first field training was they choose some AC pipe 350 millimeters. based on the history that had lots of bursts. There was expensive repairs. The most of the burst was on the couplings, and the rubber is just in the, it's gone, and they had lots of leaks. So first of all, we tried to explain them how the correlation works, and we used the hydrophones because there was a long stretches. The average stretch for the correlation, average length of the pipe main was around 300 meters. So we started using hydrophones. We connect the hydrophones to the hydrants or the service connections, and started showing the guys how it should be performed, entering all the details inside the pipe, and to see can we catch some of the noises on the field. Unfortunately, on those locations that they choose, we didn't find any leaks, but everything that we caught on the spikes on the correlation graph, it was caused by the consumption of the house and the service connections. So we told them that. So now we understand that every noise, if there is any noise caused by leak, we would hear it, because every consumption we can see on the correlation graph. So in this area, in this location, they learn how to learn with how to use the software correlator, install them, and to analyze analyze the correlation graph from the leak noises. The next location was field training in a small town of Azewijn. They said they had a history of lots of bursts on the mains. So we start using here correlation noise loggers. So we cover the entire network with the noise loggers. They help us to install them. The average distance between noise loggers was around 100 to 150 millimeters, 100 to 150 meters between the loggers. And the 90% of the pipe material in this area was AC. So we installed the noise loggers one day, and the other day in the morning, we went there to collect the data. And as you see on the screen, there was a leak score was 0. So the network was totally quiet. There was no leaks over there. In the entire distribution network, there's very, very quiet, not even in decibels, there was very, very low. So we confirmed to them there's another area where they thought there was probably a leaks. We didn't find anything. But now they met how to use, they made a correlation logger, and they understand how to use it and on which materials to use it, which pressure. So we try to explain that we can't use the noise loggers with low pressure and the plastic materials. I have to apologize, the screen is slow, so I still see the same. Oh, yeah, okay. The next location was field training in one small town, Angerlo. They told us they have a suspicious location over there. So we said, let's go try and check to find the leak over there. After we installed the equipment, as you see in the picture, we install again hydrophones on the hydrant and everything. The distance, correlation distance was 505 meters. And on my surprise and my big happiness, we had a nice peak on the correlation graph. And we said, yes, finally we have a leak over there. We found a leak on 154 meters from the B unit. So we went there and we found that leak was visible. It was surfaced out. So I said, okay, but we have it surfaced out. And they say, yeah, they reported this morning. And I said, okay, but why did you ask us to try to find it? Well, we wanted to see, can this equipment work, and does your methodology and everything that you said is can we apply that on our system? Well, now we see that everything that we learned and everything that you showed us, it's working because we found a leak. Even you found a leak, even you didn't know there is a leak. So we confirmed them that equipment works, that everything they learned works, that everything makes sense for them. So they now knew if there is they have some suspicious location where to find leaks, they will be easy to find it because the noise transfer in their system is very good. And all the leaks, if they appear, we can find with the showed equipment, with the hydrophones in correlation. What they didn't know, where is there a leak, in which location it was a leak on the, because they had two pipes running on that location, and the same location where we pinpointing. They tried to pinpoint and they said, yeah, the leak is on this valve, not on the other side where the water is coming out. So that's another thing they learned, how to use the ground microphones and listening stick to pinpoint the leak, the exact leak location, that they wouldn't dig on the both sides of the pipes or on this place where the water is running out. Okay, Cor. Okay, here's another location where this part of this distribution network was heavily damaged by storm a couple of months earlier, and they asked, can we do the leak detection to try if is there any more leaks in that area, because they fixed lots of leaks over there. They want to just to be sure there is no small leaks or any other leaks that they didn't surface out. So again, there's everything is 90% of those pipe material is AC. So on their request, we install again with them noise loggers, correlated noise loggers. And next day we collect the data, and on their happiness, we just confirm there is no more leaks in that section. So everything they repaired is okay. So this part of network was also good. And like I said, they in this part of network, they use the noise loggers by themselves. We were just helping them, but everything on this part of network, they do it by themselves. Okay, now there was a trunk main where they had a couple of leaks. So they asked, can we try to measure and try to learn them how to find the leaks on the trunk mains. So they dig 2 holes where we installed the ultrasonic flow meters. So we'll teach them how to install the flow meters on the mains. They program everything, and we install the noise loggers and offline correlators. 6 noise loggers and 6 offline correlators, just to be sure if they can catch something, we will have a double insurance. There is a leak. But after 3 days, we download the data from the flow meters and from the noise and loggers and correlators. And the data was exactly the same as you see on the graph. When the pumps are working, there's no difference at all, maybe just an error of 1% of the ultrasonic flow meter, because the pipe was, everything was good. There was no turbulence or anything in the pipes. And when we download the data from the noise loggers and correlation, they also didn't detect any leaks. So we have a confirmation from 3 points from the ultrasonic flow meter, noise loggers, and offline correlation. There is on this trunk main pipe, we didn't have any leaks. And that was very important for them, because they had a couple of suspicious location. They have a couple of leaks. They try everything over there, even a gas insertion. They insert gas. They have a suspicious location with the gas, but they dig and they didn't find anything. So in this location, they learn how to install the ultrasonic flow meter, try to localize and locate, do they have a leak on some in some trunk mains. Okay, Cor. And this was one of the most interesting part of our job. So in this small town, Osterbeek, we try to start from the beginnings. We try to do all three methodologies: localize, locate, and pinpoint. So we Osterbeek Hog, the north part of the Osterbeek, as you see on the picture, we separate it on two parts. I mean three parts, but the east side, that was we dig a couple of holes because they don't have any chambers, anything where we could install the flow meters. So there was entire Osterbeek Hog has a 26 cubic meters per hour night flow. So we said we want to see why and where it goes. So Osterbeek East has only 3 cubic meters per hour that we measured. Osterbeek Hog West has almost the same area, has the same area in pipeline, has 10 cubic meters per hour, and the next 13 cubic meters per hour is going to other side, to the other town, Dorwert. So we said, okay, our focus should be on Hog West, because there it's the same size of the Hog East, and there is 3 times more night flow. So now we've done the localization in that town. So our focus was on the Osterbeek West. But during those measurements, the guy said there is a couple of pressure zones, boundary valves, and they said they checked those boundary valves, and the boundary valve is not leaking. So we said that we want to try again also to listen all the valves, and on our surprise, we found 2 valves they are passing through, and they said it can be true because we listen to them and we try them and we tighten it and it's not leaking. So we use our electronic listening stick and we listen to those valves and we show them, and they try to, and they listen, and they said after that, yeah, it's leaking, it's water passing by from one zone to another zone. So after we tighten that valves a little bit more, so water is not running, we reduce the night flow from 13 to 9 for 4 cubic meters per hour. So they learned that their instruments and their way how to listen the valves, boundary valves, is not good enough. So they understand they need to have a better equipment to do the leakage detection, and especially to listen all the boundary valves to see are the PMA and DMA zones are tightening, the valves are close enough. Sorry, it's very slow. Yeah, and the Osterbeek, we was doing leak detection in Osterbeek West when we had a 10 cubic meters per hour night flow. So in 2 days, we covered approximately 80% of the mains. And we were doing the, after locating with listening all fitting survey, we listening all service connections, all the valves, hydrant. We try to listen everything to try to find the leaks. My idea was to do the step testing also in that area, but unfortunately in Vitens that's impossible, especially you need to tell the people at least 1 month in advance that you are going to do some step testing and closing valve during the night. So that was impossible to do in those 2 days, but I was hoping that we would find those leaks in doing with the step testing, and the guys should learn step testing, but unfortunately we couldn't do that. So we'll do only the all fitting survey, and in 80% of the mains we couldn't find anything. Only what we can found is consumptions. You can see that here is one correlation that we've done, and there was a leak on 54 meters from A unit, from the A sensors. And we went there, okay, I said, great, we have something over there. So we went there, we saw the service connection for some house, and the house was 20 meters, the service connection was 20 meters long, and we were knocking down on the guy came out and he said, yeah, I was showering, I was using water. So we make a laugh and says, sorry for interrupting. So we know if that's in their system, if there is a leak, we would definitely find out, because if we can hear that somebody is showering with the equipment, we know there is a leak, we will be find it. So the guys, the team, the staff that was working with us, they were very satisfied, because they had already some plans where to use the equipment, what kind of pipes they need to check with the hydrophones, because there's lots of pipes going under the river and under the highways and everything that's never checked, and they may be leaking. So they now understand that with this equipment and this knowledge that they received, they can check all those kind of pipes. And the last location, that was in Friday morning, that before we left, they had suspected a leak in one rural area where they have a pressure drop of 0.4 bars, and the same time they have an increase of 20 cubic meters per hour of flow. So they suggest that we go to some direction in some area where they suppose there is a leak. But unfortunately, we didn't find their leak, but we found out there with the correlation, everything that was leading us to some other side of that area. So we tried to close the valves, measure the pressure, so we done some measurements, flow measurements and pressure measurements, correlations. So we tell them, go focus on the other area. Here, there is no leaks. So after we left, following up the staff that was trained by us, a couple days later, they found those 22 cubic meters per hour leak with clamp-on flow meters. And I'm sad that we couldn't be there to try to pinpointing and locate it with ground microphones and with hydrophones, so it will be more precise. Now, those 2 weeks, just in conclusion, in those 2 weeks, the people are very satisfied. They learn a lot, and they start to using that knowledge that we gave them to them. And I think that Cor will save a little bit more with everything they learned. They found a couple of more leaks, right, Cor?
Yes, indeed, Tomislav. I can tell you that Vitens was very satisfied with what you and your team have been doing. It was a great training program, and yes, it's difficult to find leaks in a utility that doesn't have that much leaks. Localization, that's what I started with, was done by ourselves, based on history of burst. Now, perhaps that's not the best indicator. So we have to improve on localizing things. But once again, the knowledge transferred is picked up very fast. There's also enthusiasm in the team that has been trained, and for sure, the staff members that have been working closely with you, they continued. And in 2 weeks after that you and your team were left the Netherlands, they not only found the 22 cubic meters per hour that was in Culemborg, in the where you only could spend half a day where you convince them if you could have spent a whole day there, you should have found it. But it is not only that one. The most experienced man continued in another area, and by using the ultrasonic clamp-on flow meters, he was capable in narrowing down a leak that in the end was a leak of 46 cubic meters per hour. And here you can see why, because this is the bend of the pipe necessary at that location. And here you see that the connection absolutely was, the rubber was absolutely not in place anymore. And this did leak for 46 cubic meters per hour. It did not surface at all, only when they start digging at that location and the first spade of soil was removed, water was surfacing at a certain stage. So once again, without better understanding how to find leaks, how to use flow meters, but the noise equipment, this one should not have been found. And it is also the enthusiasm that was transferred to the team. They know that they can add value by being very careful on trying to detect leaks. And they know there are not that much leaks, but they are going to improve. So once again, this is a utility where pressure management has been implemented. Speed and quality of repairs is organized. There is professional asset management, and there is an allowance for making asset replacement. Asbestos cementers is a big topic in the replacement program. So yes, we still believe that we can reduce leakage by faster detection of the unreported leaks. That training of professionals by professionals is required if you really want to pick up it very fast. And that's done because in 2 weeks' time, to burst 2022 and 46 cubic meters per hour. Also, the learning that the maintenance of boundary valves is crucial. Not each valve indicating closed is really a closed valve. And the second thing is that they have to improve some work on hydrants, because if you want to connect one of the noise blockers or the hydrophones to a hydrant that is leaking on itself, then you hear the leak noise of that hydrant and not the leak that is in the pipe. And most important, I think, is that the maintenance staff is really enthusiastic. And once again, they recognize the added value they can have to the utility. And also they see it as a new challenging task. They did not have the experience. They are going to purchase equipment, and they are going to use it for a variety of tasks. Amongst others, the checking of the boundary valves that's already addressed in the year program for next year. But also in a utility that did not have leak detection, we have a total of 2.2 full-time equivalents available next year for doing this work in 2 duos of 2 trained staff members, where all others will assist and join when necessary and when the leak is in their cluster. So that's, I think, a phenomenal result. 2.2 full-time equivalent doesn't seem that much, but compared to the 1 person that did it more or less as a hobby, it's a large improvement already.
I just want to add that it's for them, it's not a problem to find a leak. The problem is where to find the leaks, where to go to find the leaks, because there's a big system and they just need to localize where to search for the leaks. The leaks are there, maybe smaller one, but the first step is to localize where to go to search for leaks, and their system is well maintained. And if there is a noise, if there is a leak, they will be fine. But the main thing that for them is just to do the proper localization, where to go and search for the leaks. Like I said, if you can't measure it, you can find it.
Hey, this is it. We are available for questions now. I saw in the chat already some questions. I can stop sharing now, and then I can read the questions. But perhaps, Milena, what is the first one that you say? Okay, spend your time on answering this one.
Mm-hmm. Okay. Would you like me to read the questions for you, or are you reading and answering?
Yeah, but please do so. Yeah.
Okay, so the first one, Paul Farner, apparent losses is firefighting metered. I'm not sure if I get.
Yes, it's metered, Paul. Reason is that most fires are firefighting takes place with the 1.5 cube of water that is on board the truck, and trucks are filled at the filling station at the fire brigade. So there is a limited consumption of water from hydrants.
Okay, we have another one from Jeremy Heff. I'm not sure if I'm pronouncing this right. It's how large are the monitoring zones and what is the frequency and granularity of flow monitoring?
A flow monitoring is taking place continuously, so 24/7. It's taking place at the waterworks, all outgoing pipelines, but also from storage tanks in betweens. All flows are measured. Then, because pressure management is implemented everywhere, the pressures are also measured on well-selected and well-designed locations inside each of the water balance areas and water balance zones. And it's on a 5 seconds frequency, but then of course the data is then stored and packaged unless there is an alarm, and that's then coming from the leak monitoring. But in the OSIsoft Pi software, the data is then packaged for analyzing from our screens at a 5 minutes basis. So that's the density of the information available. So the all flow and pressures in trying to analyze afterwards is done on 5 minutes data.
Okay. Jan Arenas asked, what is the incidence of firefighting water metered or unmetered? I think I already said something.
Yeah, I think I already answered. It's predominantly the 1.5 cube on board of the firefighting truck that is being used for firefighting in the Netherlands. So there are even utilities that don't have a contract anymore with the fire brigades that can remove their hydrants from the network. That's not in Vitens' case, but two utilities, 2 out of 10 utilities in the Netherlands can remove their hydrants. They keep them in because hydrants is also important for network flushing. You can use them for network flushing, and that is an indicator that the majority of the fires can be extinguished with 1.5 cube. And if it can't, it's such a large house, then you really have to have a good insurance.
Okay, David Andrew Fernandez is asking, all the 80 water balance areas are pressure managed, all with PRVs. What is the average pressure per water balance area? Thanks.
Yeah. Hey, to answer the last part of the question first, is everything between 30 and let's say 35 meters. In general, there are some higher areas in this cluster Gelderland Noord. So the highest pressures that we are confronted with is 45 to 46 meters. No, there are limited to none pressure reducing valves, PRVs, in the network, because in the end, the water balance zones are fully measured with flow and pressure. And of course, there are some boundary valves. So where needed, the boundary valves are closed. And so the balancing is purely done on virtual balancing based on flow metering.
Okay, Jean Arenas is asking, did the team have available pipe cross sections to accurately enter the characteristics into the ultrasonic flow meters to reduce the margin of error?
Absolutely, absolutely. And Tomislav was granted access to the database, MapKit was it called, and everything is in there. You can look to the history, you can zoom into a valve and hydrant at that level, when it was repaired, when it was checked for the last time. So the GIS system of Vitens is phenomenal. It's almost 100% coverage. And the only thing that they are improving at the moment is the service connections. But on the level of the mains, my experience in the Netherlands is that the GIS systems are accurate and up to date.
Yeah,
Tomislav,
I just want to add, because when we do the flow measurements with ultrasonic flow meter, the speed of sound through the water is 1,460 meters per second. So that's another way how you can check the accuracy of the water and the parameters of the pipe. If you miss the parameters of the pipe and you put the sensor on it, the speed of sound will be 1,400, 300, 1,560 or something like that. So as you much closer to the 1,460 meters per second of sound velocity through the water, you know that your parameters are correct. So we are not just looking for the sound signal and quality of the signal, through the pipe from the sensor. We also check these parameters, so we know that we have a great parameters and that accuracy is very, very accurate.
Okay. Also, Jean Arenas is asking, assuming 2-person crew, how many miles of pipe does Vitens expect to be surveyed, sounded per day?
I think this is a great question. All others are great also, but this one I like very much, because the whole idea is not to have a target of kilometers of mains. Now, it's absolutely that we want to improve our localization, and that's based on a prioritization of those localization. The team then is being scheduled for doing the locate and the pinpointing activities with the equipment that they are going to purchase. So it's one of the tasks I'm having now is to further improve the collaboration between the people inside the office that work with the network models, with the GIS, and are checking the dynamic bandwidth monitor and the leak monitor and the minimum night flow monitoring, and the people outside that bring a lot of knowledge of the network outside. So it's the inside office outside in the field, but also the field experience, transferring that to the people that work inside and are not that often in the field. So it's the inside out, outside in that requires me to that's the task to improve, because the localization, absolutely like Thomas has said, is something that Vitens has to improve, because it's impossible to do the leak detection of all 50,000 kilometers of mains they have available. That's an undoable job. So it's really trying to localize as good as possible, and then go to that 5 to 10 kilometers of mains, which then can be done in a day or so with one duo of leak detectors. Tomislav, can you add something to that?
No, you said everything,
Thank you.
So Paul Farner is asking, Cor, you? No.
Yeah. I can read the question. Hey, Paul,
you started by. No, that's okay. I just wasn't reading it correct. Cor, you started by saying it's a totally open system, but it's clear that Vitens do manage pressure and have boundary valves. So what do you mean by the open system?
It's it are the exceptions, Paul, that have the boundary valves. And yes, there are valves closed also in, let's say, pipes of diameter 100. But in general, the pressure management is done at with variable frequency drives at the water treatment plant, feedback from the well-selected monitoring points. And then where the area of influence of one waterworks ends, it also ending of the next door waterworks, so more or less at the point where there is an open main that crosses the boundary of the water balance area, there's a flow meter installed. So it's absolutely the large majority done by virtually boundaries. And only in the areas where we have some, you can't even call it hills, because it's 30 to 40 meters only. But that's small height differences. That's where the boundary valves come into play. In this Oosterbeek area, you perhaps recognize the name Oosterbeek if you are watching the Second World War movie A Bridge Too Far. It's that area. That's also why we have selected this cluster for gaining the experience that Tomislav brought to Vitens.
Okay, Chris Lauber is asking, Tomislav, for non-metallic pipe, have you been able to correlate leaks at a greater distance with hydrophone listening in the water column versus accelerometers listening on the pipe wall? If yes, can you give an example of how much greater distance?
Well, of course. In Vitens, we correlate around 300-400 meters distance, and we caught, like I said, only spikes with where the consumption was. But on the other projects, we found most leaks on the PVC pipe only with the hydrophones, and there was a distance between around, let's say, average of 200 meters, something like that. And there is no problem to do the leak detection with hydrophones. But like I said, also depending on the pressure and the pipe condition, it's not a problem to do the leak detection with hydrophone to find the leaks. In Croatia, we found a leak on PVC pipe, 4-inch main on 180 meters, something like that. It was clear spike and it was nice leak. And also, I'm right now in Bahrain. We were doing also leak detection. Yes, last night we do the correlation on the PVC pipe. I think it was around 90 meters, something like that. We caught the spike, we caught the leak, and that's it. So if you want to use hydrophones, it's a must. For all non-metallic pipes and low pressure, hydrophones is a must. And you're really going to have a great results if you're going to use them.
Thank you. Chris Lauber is asking, Cor, are you considering installing additional pressure sensors to help with localization?
Yes, there's a program also in this cluster to add some additional pressure loggers, but the pressure loggers are almost always there where they are needed for the pressure management. In one of my previous answers, I gave that there's a feedback from the selected pressure measurement points back to the pumping station with the variable frequency drives on the pumps. So that's one thing. And the leak monitor, I did explain the dynamic bandwidth monitor, but the leak monitor is also installed on crucial trunk mains. And they measure indeed the drop in pressure and the increase in flow, which is also an indicator for a leak on that trunk main. So there is where needed enough pressure management. But yeah, Vitens with this size of distribution network, it's very crucial that you pick the correct places to place additional sensoring, because it's impossible to put sensors everywhere where you think they could be useful. It's very important to select those locations very precisely for the function that you are going to use them for.
Farney is asking, Cor, you mentioned you're investigating the background losses with Kate. What are your findings?
Now, Ellen is helping me with the unavoidable background losses. The short story to tell, Paul, is that the leakage that Vitens has in 2020 is already comparable to what the results of the unavoidable background losses that we calculate using the equation that is being used for that. And we know that we have the under registration of 1.8 to 2% with our current residential flow meters. So there's something going wrong in our mathematics. So this is very important thing, because if the unavoidable background losses are indeed that high, following the equation, then it is almost impossible to really find and discover leaks with the leak detection. So that's one thing. And what we are going to do with Kate is indeed for the first set of 13 water balance areas. So 13 out of the 80 that we have, we are going to do the unavoidable annual real loss calculation with the system correction factor to establish what we can learn additional when we bring in more key system specific information in that equation.
Okay, we are heading to the end right now. I'm gonna ask your final question here. If you guys attending here have any other questions, you can send it directly to them. Let's try to do this last one here, Cor. John Arena is asking, using the GIA's database, do you envision using AI to generate automated leak sites on a 3-day basis, accounting for variability?
Yeah, that's absolutely done because it's not only this training provided by Tomislav and his team, but also we try to schedule an exercise, a proof of concept with Astera. So the leak detection with satellites, with AI. So also the GIS information is being collected for that. There's currently a digital twin being developed, but what is really restricting the use of AI and monitoring on a daily 24/7 basis is the fact that our residential water meters are only read once a year. So that means that consumption of customers, residential customers, is only becoming available on a yearly basis. And then the enormous size of Vitens means that they are also having months in which they do a certain area. So it takes close to 1.5 years to absolutely exactly know what the billed consumption of customers was. And then looking back, we absolutely established that customers have paid what we have supplied. But that is one of the things that's at the moment limiting the analysis capabilities of Vitens. And once again, if you have 2.5 million service connections, residential water meters, it's also a very expensive and time-consuming exercise to replace all meters by smart meters. So the discussion is ongoing, but based on the very limited leakage that we have, yeah, there is no business case for changing from the traditional water meters to smart meters at the moment. Only for gaining that limited leakage back.
Thank you, Cor. Thank you, Tomislav. We have 1 last minute for your final considerations, and thank you to everybody. Would you like to say something else?
Or
Nope, that's it.
No, I'm always happy with the good discussion and the conversation that we have. I really like these questions, and I'm always in for presenting more. And I'm always happy to listen to the presentations of all other experts. So thank you very much being part of this large water loss specialist group. Thank you, Milena.
Thank you, Cor. Thank you, Tomislav, for this great presentation. Thank you, everybody. We are closing the room.